question 3.1. It says that at a school function, learners pay $2.50 entrance fee, adults pay $12.50. Then the total income on a certain day is $16.50, and then there were 320 people at the function. How many adults attended? Now, when you're given a question like this, what you do is you introduce variables. Okay, that means you can say let x be the number of learners and let y be the number of adults. Okay, so here I'm not going to use x and y. I'm going to use L and A just because I think that will be easier to understand. A is for adults and L is for the learners. So I will say let L represent the number of learners. Okay, so I just state that so that the person who's marking knows, oh, this is what this represents, this is what that represents. So I don't just introduce variables and without explaining them. Okay, and then I will say let A represent number of adults. Okay, so I have my two variables. I have L, which represents the number of learners, not the price of a ticket for a learner, the number of learners, and also the number of adults is represented by A. So the question here said how many adults attended. So what am I actually interested in working out? I'm interested in working out the value of A, not in L necessarily. It might help me to know what L is, but the question is really just asking you what is A? How many adults attended this function? Okay, so when we look at this information, we have to try and represent it mathematically. It's given to us in words. Let's represent it mathematically. The first sentence says that learners pay $2.50, adults pay $12.50, and then the total number, the total income was $16.50. Now, if you want to work it out, I'm sure you can imagine if you're the cashier at this event and then you are told the number of learners who attended is this much and learners pay $2.50, and the number of adults who attended is A, and adults pay $12.50, and altogether we made $6.50. I'm sure already you're thinking this is an equation that I could write. So here, I hope this is what you have. We have 2.5. I don't need to write the 0 times L. So this 2.5 times L, this is $2.50. So I also do not need to write the dollar sign. Okay, and when I add that to the $12.50 that each adult is paying, and then I multiply by the total number of adults, this gives me the total amount that the function raised, and this should be $16.50. Okay, so I see how many learners do I have. I multiply with the amount that the learners pay, and then how many adults do I have. I multiply by the amount the adults pay, and when I add everything together, it should give me $16.50. Now, we're also told that the total number of people who attended was 320. So when I add all the learners, this is the number of learners. Remember, we represent L represents the number of learners. Okay, so all the learners, and then I add all the adults. This should all equal to 320. Okay, now I'm sure you can see I have a simultaneous equation that I must solve. And here, remember, okay, this is an exam, so you do not always want to do more than what you are asked for. The question says how many adults attended. So all I need to do is solve for A. If you have time, it's a 3-hour paper, so some of you might finish earlier. If you have time, go ahead and find learners and then check if your answers are correct. But if you're sure what you're doing is correct and you work a little bit slower, try and only do what you are required. There's no need to go above and beyond. Okay, so I want to find A. So I'm going to solve these two equations simultaneously. This question doesn't say for me to use elimination or graphing, or it doesn't specify a method. So I will pick what I like or what I am comfortable with. It is good when you go into the exam, you have an idea, or you know how to solve each of those you know how to solve the simultaneous equations in each of those ways, so that if the question is specific, you're able to do it. But when you don't have a restriction here, pick whatever is comfortable for you. Okay, so I am going to use elimination because that is what I like to do. So with elimination, I'm going to multiply this equation by 2.5 because I want to eliminate L. So my first equation, this is number 1, it's not going to change, so I'll have 1 over here, so it's 2.5 times L plus 12.5a. This is equal to 1650. So remember, I want to solve for a, so what I need to eliminate is L. So I multiply this equation 2. I say I will multiply this by 2.5 because I want the coefficients of L to be the same. So it's 2.5 times L, which is 2.5L, and then A times 2.5, this is just 2.5A, and then I say 320 times 2.5. This I just do on my calculator. Say 2.5 times 320, I get 800. So this is equal to 800. And then here I look at my coefficients. They are the same. The signs are also the same, so I'm going to subtract. Okay, so I have 2.5L minus 2.5L, that is 0. Then I have 12.5A minus 2.5A, this should be 10A, so this is plus. And then I have 1650 minus 800, my trusted calculator, 1650 minus 800, that is 850. Okay, so I can rewrite this equation without the 0, so I have 10a is equal to 850. Remember what I want. I want a, which is the number of adults, so I divide by 10, divide by 10, I get a is equal to 85. Then I just write a sentence. It doesn't have to be long and very grammatically, nice. That's not grammatically nice. Okay, it doesn't have to be fancy in any way. It's just a sentence to show that you understood the question and now here is the answer. The question was given to you in words. It wasn't an equation. So also answer it in that way. So you can say the number of adults who attended the function is 85. And I'm sure you can think of shorter ways to do that or to write that. You can say 85 adults attended the function. I will understand that if you say it. Okay, so just like that, you're done with question 3.1.